Welcome to Civil Constructions. Today I want to discuss about how to design a circular tank with flexible base. Design a circular tank with flexible base. And capacity of water tank is 300 kiloliters. And the depth of water tank is 3.8 meters. And assumed freeboard is 0.2 meters. Adopt M30 grade of concrete and Fe 415 steel. Now we start the solution. Given depth of water tank equals 3.8 meters, water tank capacity equals 300 kiloliters. By unit conversions, in meters. Capacity of water tank equals 300 meters cube. Now, depth of water equals depth of tank minus freeboard. Equals 3.8 meters minus 0.2 meter, then depth of water equals 3.6 meters. Step 1. Calculation of diameter of the tank. The tank is circular tank, so the volume formula of cylinder equals pi by 4 into d square into h. Now, capacity of tank equals volume. After substituting the values I got diameter of tank equals 10.3 meters. For water stored, gamma W value equals 10 kN per meter. Now, maximum pressure at base Pa equals gamma W into depth of tank. Pa equals 10 into 3.8 equals 38 kN per meter square. Maximum hoop tension formula, T equals Pa into D by 2. Equals 38 into 10.30 by 2. Hoop tension T equals 195.7 kN. Step 2. Calculation of hoop tension reinforcement. AST equals T by sigma ST. In AS Code 3370 Part 2 book, the permissible values will there. For M30 grade, sigma CBC equals 10 Newton per millimeter square. And sigma ST equals 130 Newton per millimeter square. By substituting values, AST equals 1505.38 mm square for two faces. For one face, AST required equals 1505.38 by 2 equals 752.690 mm square. Assume 12 mm diameter bars. By calculating, I got spacing equals 150 mm center to center spacing, and AST provided for one face equals 754 mm square. Hence, provide 12 mm diameter at 150 mm center to center spacing. For two-face, AST provided equals 1508 mm square. Step 3. Calculation of thickness of wall. Here, the formula of tensile stress is sigma CT equals capital T by 1000 into small t plus m minus 1 into AST provide. Capital T equals 195.7 kN. Sigma CT value equals 1.5 Newton per millimeter square. For M30 grade, these values are in AS Code 456 book. And modular ratio formula equals 280 by 3 into sigma CBC. By calculating modular ratio, M equals 9.33, AST provide value already calculated equals 1508 mm square. Now by substituting these values in the tensile stress formula, we got thickness value 117.89 mm after calculation, and I adopted thickness small t equals 120 mm. Step 4. Calculation of vertical reinforcement. Now, here provide maximum thickness as 200 mm. Thickness lies between 100 to 200 mm. And I adopted thickness capital D equals 100 mm. Now by calculating, AST minimum equals 240 mm square. Assume 8 mm diameter bars. After calculation, spacing value equals 209.43 mm. AST provided equals 251.3 mm square. Hence, provide 8 mm diameter at 200 mm center to center spacing. Step 5. Design of base slab. For base slab, I assume thickness 150 mm. We should assume thickness less than 300 mm. Our assumption is okay. Now, we should calculate reinforcement calculation. Capital D equals thickness value adopted by 2. I adopted 150 mm, so capital D equals 150 by 2. Capital D equals 75 mm. Now AST minimum equals 0.24% BD. After calculation, AST required equals 180 mm square. I assume 8 mm diameter bars. After calculation, spacing value equals 270 mm center to center spacing. AST provide equals 186.14 mm square. Hence, provide 8 mm diameter at 270 mm center to center spacing. These are the steps are calculated to design a circular tank with flexible base. Thank you friends for watching our channel and please subscribe our channel.